Today I'm showing you DSPy, which is a declarative framework for AI software. I'll show you 5 real-world use cases building up in increasing complexity, starting with simply showing how to do structured output with DSPy, and then chain of thought, RAG, an agent, a simple React-style agent, and then building a self-improving pipeline to iterate on our RAG example. If you are just getting started with DSPy, then this video will be perfect. But even if you've used it a little bit before, I hope that this video helps you understand a little better what's going on under the hood. We're going to be inspecting the OpenAI platform to actually see what literal prompts are being created by DSPy. And that is the key unlock to understand how this library works. One quick caveat to note is that by the time you watch this, the library may have evolved. So I'm using DSPy version 3.01 or something like that. But it's version 3, it's the major version 3, so hopefully everything's pretty well the same. But if not, you can easily update these examples to the recent version of DSPy. The core fundamental concepts I'm talking about here will be unchanged. You can think of DSPy as a higher level language for AI programming. So rather than speaking in like the most base language, which would be prompts with text, we're thinking now programmatically and sort of building these building blocks of code that create the text for us. That's what DSPy does. And I found this library really difficult to use. I think it's notoriously difficult to get started with, but this library, which comes out of Stanford, is pretty amazingly powerful, and it does a whole lot of stuff. So let me get you started with that right now. Let's get to the demonstration. I highly encourage you to download the source code so that you can run these examples yourself. I'll show you exactly how to do that in this video. And by actually running these and getting your hands on the code, that's how you'll really learn and solidify these concepts that I'm talking about. And if you're learning AI engineering, then you should subscribe to my email newsletter. I just send 1 email a week to go along with my new video release. And when you sign up, I'll send you some free digital downloads that I think you'll enjoy. So to get started, we're going to set our system up, and I'm going to install a virtual environment with Python and then activate that. And you can see that's active. And if I was to ask which Python am I using, it's the one that's in this current virtual environment right here in this folder. Here it is right here. It created this folder for me. And now I want to install these requirements. And the requirements we'll need are DSPy 3. And this is the version we're going to peg these examples to, but I'm hoping this will be like at least good for hopefully like 6 months in AI at least. I don't know. I'm hoping version 3, everything will be consistent with that. And we're also going to use OpenAI and .env and then sentence transformers for creating some local embeddings. So if you have any problems with this, you can install them one at a time, but otherwise you can just say pip install -r requirements. Next, we want to create a .env file, and this is what mine looks like. I'm going to have to delete this key after since I've shown it to you, but you'll want something like this where you're defining your OpenAI API key, and then this is the key that will be used to run the demonstrations. And these are going to cost us some money. Before I run the first example, I should talk through it so we completely understand what's happening. So I've just gone ahead and opened up this O1 structured output extraction. The purpose of this file is to take a bunch of emails and turn them into these structured JSON tickets. And if I'm going to come down and explain some of the later parts first, then I'll come back to the top and we'll talk about how the language model is initialized. But this is the ticket. This support email is going to be the task structure, which will declare the input and the output fields. So we're inputting an email into this kind of DSPy pipeline thing, and then we're going to output this stuff. We're going to determine the subject of the email, the priority, the product, and if the sentiment is negative or not. And how this like hooks together with DSPy is we take this class, which is a signature, and then we create like a function called extract ticket, and that is done by initializing this class DSPy.predict and passing in support email as an argument. And once we do that, we can simply call this thing and pass in any of our input fields, which in this case, we had 1 input field, and that was an email. So let's go back. We're going to follow this back now that you've seen how this works, right? This is a function that we call. It's initialized by instantiating a DSPy.predict object, and the argument to that is the task signature. And the task signature has that 1 field for email, which is why this is why we're inputting email down here, because it's an input field. And the rest of the stuff are output fields. So we're going to see these come out of our prediction of whatever DSPy does for us. And I'll show you actually how exactly this works with GPT-5 using I'm going to show you the literal prompts that DSPy is about to generate for us when we do this. So load.env loads our API key, that's basic. And then we're instantiating a language model object that's OpenAI GPT-5 Nano. And I have a temperature and max token set here, which I'm going to explain in a minute. But once we've configured DSPy, now anytime we're doing stuff with DSPy, like this predict and all this stuff, it knows about what model we're trying to use for this. And when we see output, it's going to be because of this stuff. This is where I'm actually running stuff for this function and outputting things. So I'm going to run this now. And it runs super fast. Look at that, it's already done. So this is the first part of what it updated or output, and it's outputting these structured tickets for us. So this is that print statement, structured ticket, and then we print the prediction. And the prediction is the result of this extract ticket. So this function right here, when we actually call that, we get a prediction, and this is what the first one looks like. So now let's look at our training example, like the emails. We're iterating over these sample emails, and the first one looks like this. Cracked screen after 1 week, and we got that as a subject here. Cracked screen after 1 week. We're determining that this is a high priority, and this is the product being referenced, and that it is a negative sentiment. And at this point, let me explain these things. So the subject is declared with an output field, and we're describing. This should be the subject line of the email, but a description for the output field is not necessary. And here, for priority, I'm not describing anything to do with the output field. I've left this blank, and I'm just saying this is some literal, okay, so Python has this literal type hinting object, which is super handy. And what it says is this is a string, which is either going to be low, medium, or high, but it will never be anything other than those three things. So it's kind of implicit that this, we should just add a priority label. And so I don't need to describe that. For product, it's a string field, and I describe the product, and I also have some other rules, like, hey, just output empty string if you're not sure. And lastly, for the sentiment, that's a Boolean object. And so that's why we're getting, down here, we're getting a Boolean object returned from this prediction here. So I have a couple other examples, like we've got this subscription renewal, and we do stuff, and then this one's kind of cool. It's your #1 fan, loving your alpha tabs. And we can see down here, we're like, yeah, alpha tabs is the product, and we found the subject. Fine. But next, the last part of this example, before we move on to the second, is this part right here, where we're outputting the DSPy history, and I'm calling DSPy.inspect history. And this actually explains what DSPy has done. Remember, DSPy is a higher level abstraction on AI programming. So the abstraction is all of the code we've been seeing up here. And this is kind of like how it compiles that for the assistant, for the AI. I'm going to make this bigger so we can fully see this. So it creates a system message for this example, and it says your input fields are email, just one thing, and this is what you're going to output. And all interactions will be structured in the following way. And it's using this kind of weird syntax here to delineate different items that we're going to be passing in when the user puts data in. And so coming down to the user message, this was the actual user message that was run, and this is that alpha tabs Jeff example. And we can see we're using the same tokens, like characters, to delineate this content in here. And the idea is this is going to be like a unique string, which we won't often see, because we wouldn't want an email that actually contains that. That might kind of screw some stuff up. And yeah, and then so we're saying respond with the corresponding fields, and this has the output, like a reminder of the output fields, I guess, that we want to do. And then we get this output, and this is what the model has returned to us. And then DSPy takes that, parses it, and converts it into this prediction object. And I can show you this as well in the OpenAI platform. I'm here in the Logs Explorer for my project with my API key, and these three prompts are what we just ran in this example. This stuff down here is for a later example that I'll get to in the video, but if you just look at the date stamps, 12:45 is like the current time. So these are the three ones that were run. Let's have a look at this alpha tabs #1 fan. And this is the text that I was just showing you in our terminal, but here we've removed all the new lines and stuff, so it's harder to read. And we can see the output down here. This is what the assistant output. This is our subject, this is our priority, this is our product, and this is the data we parsed. We can also see how many tokens that we used. And you can immediately see that even though the data we got out was pretty straightforward, DSPy is kind of expensive because we're adding all of these extra tokens and characters, and there's kind of some redundancy as well in here. So this is a common theme with DSPy where it's really nice, but it can have these kind of hidden costs and it's difficult. Another thing right now is it's still in the completions API, whereas it should be using the responses API, but I'm sure that will be updated very soon. And another thing I want to demonstrate with this example is this line right here. So when we're configuring DSPy, I've set temperature to 1 and max tokens to 128,000. This is the maximum number of output tokens that GPT will allow. You might want to tone that down a little bit, but I mean, this is only going to cost like 50 cents or something, even if it does all of these. And that's with GPT-5. With Nano, if it really output that many tokens, which by the way, it probably never really would. I don't know how you'd get it to output that much. Maybe a lot of reasoning. But the point being, this is still not going to cost us very much. So not a huge problem with just running one prompt, at least. Okay, all this to say, if I get rid of that, check out what's going to happen down here. I'm going to get an error. And this is what I was seeing. It's like, oh, OpenAI's reasoning models require passing temperature of 1 and something over 20,000 max tokens. So I just wanted to explain why I'm actually doing this. I would have liked to just show you a more minimal example, but at time of filming, I have to do that if I want to use GPT-5 models. And that's the first example. So let's go on to the second one, and we're going to demonstrate chain of thought. Let me make this full screen, and we're going to start walking through this. Now, one thing I've realized is here I need to say override. I forgot that on the previous example, and so what happened is my system API key didn't override my system API key because I didn't set this override equals to true. So that was kind of, so I'm going to update the first example as well, and I'll update all the subsequent examples as well to use this. Right, so we have the same stuff at the top of the file, and this one we're going to do chain of thought reasoning, and I'm going to demonstrate this with a financial risk checker that explains why a loan was approved or rejected. And here's the sample we're looking at. Jane has a credit score and an income and stuff and some debt, and we're going to figure out if they are going to be approved for a loan or not. And here's the signature for this. So we have an applicant profile, and that's going to be this sample profile. This is going to be an input field. We're outputting a loan risk, which is going to be either low, medium, or high. And we're going to output if the person is approved or not. And my description is just very simple, approve this person for a loan, and it's a Boolean. So that's the same thing like before, but now I'm feeding this into a chain of thought object, whereas before I had DSPy.prediction like this, and then I would have put loan risk into this prediction object. Now I'm using this chain of thought. So that's the only difference between these two examples. And I'm going to show you this line above after. But let's run this simple example here that's very analogous to the first example. And we also run this in the same way. So I've instantiated this risk checker, and then I just call that, and I pass in any input fields. And so here we've just got this applicant profile. That was the one input field here that I defined, so I'll pass that in, and away we go. So let's run O2. And that's done. We get a prediction which has the fields we requested. We wanted to see a loan risk and approved, and that's what we're seeing here. It's high loan risk. She has not been approved. And the interesting part of chain of thought, what we get out of this is this reasoning field. It kind of injects a reasoning field into the prediction and in order to explain itself. So let's look at how that works. What is DSPy actually doing here? We have a system message, your applicant profile, and we're outputting this stuff. And notice how we've added this reasoning field. I didn't explicitly define a reasoning field here in the output structure, but we're getting that as one of the output fields. And let's see if we have any more information. In adhering to the structure, your objective, because so far this is a system message where we haven't actually explained what this reasoning should be. It's just a string. But obviously the model has some idea of what reasoning should be. But I think we should speak more to it. We'll write the corresponding output fields, starting with the field reasoning. So what I'm trying to illustrate with this example is that there was no text like, oh, think step by step or something like that. It was just kind of a little field where it's like, oh, by the way, output a reasoning prompt, but also start with that field. So this will be like the start. When the LLM starts actually outputting tokens, these are the very first tokens that it outputs. So I've been trying to pull this up in the logging for the OpenAI console here, and I haven't been able to see it. And for some reason, OpenAI is not logging GPT-5 Nano stuff for me anymore, which is extremely infuriating, but maybe it's a transient issue. I really have no idea. I'm gonna try GPT-5 Mini, and hopefully it'll output that for me here. Okay, so that's just finished down here in my console. Not seeing it. Nice. Okay, I got this one to show up, which is awesome. And we can see all the system message, the user message, and the assistant message with all of this reasoning. That is the same stuff that we would have seen down here. This is the reasoning in the prediction object and also here. And this stuff that we're seeing in color down here in the terminal, this stuff comes from this line right here where I'm printing inspect history. I'm calling that method on DSPy, and then it outputs like the history of what it was doing kind of under the hood for us. And now I can illustrate something else from this example. This line right here, I said I'd come back to this, and now's the time. So this is one of the things about DSPy that I find confusing. I'm sure other people do too. A lot of the examples use notation like this. And there's this shorthand form where we're saying, we want to do chain of thought, and instead of this signature, like it doesn't need that. We're not using this loan risk anymore. Instead of doing that, we're just gonna map some applicant profile to a loan risk over here. And I'm gonna show you some stuff for this. So when I first started playing around with this, I just tried to put spaces in here. And if we run that, we'll see that won't work. But it's like, it gives me a kind of cryptic syntax error. The idea is these need to be able to map to variables. So we want these as underscores in here, and also strange things like if I was to pass in, I don't know, age like this, that's not going to work because that comma is like shorthand for and a second argument as well. So we're saying, oh, not all input fields were provided. We're missing age right there. So if I actually wanted to work this, I could say sample profile and, well, let me just show you very simply. So then down here, I would put in age, and I could give this person an age. And now that'll work. So this is confusing behavior for me because it's like DSPy saying, oh, there's two ways of doing things. We can use this awesome little string short form, or we can do proper signatures using like a Pydantic style thing. Okay, here we go, and we can see, well, we're gonna see somewhere where we're saying something like this. Okay, the applicant is this person, age that. That's part of the reasoning, but the input is up here, and we're like, age has become a proper string input. And by the way, this can extend to doing stuff like this. So we could have, you know, is male, and this could be a Boolean. Probably shouldn't do that. That's kind of like profile. Or okay, so let's say we did this, and now down where we're calling this, we're going to add that in here. And let me just say false. I just want to demonstrate this will work, and then we can come up and try something else. So let's say I said no, and now it's a string. This should give us a validation error in that case. So let's see the result here. Okay, that worked. And now with the no, like I just changed, this should give me a validation error because it's not a Boolean. And so it didn't give me a validation error, which is it's saying is male should be a Boolean, but it was no. So it just didn't validate that input. So this is male, I think, really is a good example for don't push this too hard. And in fact, I don't like that syntax ever, like anyway. I like this signature syntax because it's really clear, and to me this like really gets at what DSPy is meant for like explicit validation, and this like really treating AI language like programming instead of strings, which is what this kind of seems to revert back to. So now let's go into the third example, RAG HR bot. This one implements legit RAG, like we're doing retrieval. We have this retriever down here. I'm going to talk through everything from the very top. The use case here is to do retrieval augmented generation over this handbook. It's like an employee handbook right here, and it has a bunch of different strings. This is one string, this is the second chunk, this is the third chunk, and we have a bunch of information about employee stuff like that you might want to ask. We're going to ask some questions on this. Let me clean this up because I don't need that. Here we're doing this, but we want to say override is true. Like I mentioned earlier, this one I need mini because otherwise it won't log apparently for some reason. And this one, I wanted 128 output tokens. Cool. So this is our DSPy configured, and then this thing is just a corpus. It's a list. It's a list of strings. Following this object to where we use it, we pass it into this DSPy.retrievers.embeddings, and this outputs a function called search. And I'm using that function down here in the RAG system. So let's continue talking through in order so we understand everything as we see it. But you just know that this search thing is going to get called when we're actually doing the retrieval part of our RAG system. And okay, I'm going to explain this part. We're using sentence transformers. So inside of our requirements right here, I have sentence transformers 5.1.0. There's a requirement, and this is why it's required for this example. And we're instantiating a sentence transformer object, this ST model. And this pulls in this all mini LM L6v2. So this is going to be a bunch of model weights for some neural network that will take this input text, it'll tokenize it, and it'll output embeddings for each of these. So each of these strings right here, this becomes one embedding, which has some semantic understanding of the contents of this text. This becomes a different embedding, and the embedding itself is an array of numbers. If you want to learn more about embeddings, I just filmed a video for my course, the AI Engineer Roadmap. You can check that out on zazandcodes.com, where I talk about all these fundamental concepts in AI engineering, including embeddings. I have a whole section on that. So after we've instantiated our model, we pass this into this DSPy.embedder object. This thing then in turn gets passed down here, and this is how we instantiate our search function. So it's conceptually very easy to understand what we're doing. We're passing in a bunch of strings, and we're going to create embeddings for each of these using this embedding, using this embedder, which will run it through this sentence transformer. And here we're setting k equal to 3, which indicates k is something in the embedding search that will say we want the top 3 matches for any given search embedding. And we're gonna be generating search embeddings and returning results. This is the retrieval aspect of our system. And this is how we do this with DSPy. So I'm going to create a class called RAG, and it's going to inherit from this DSPy.module. And this DSPy.module, like it'll provide, it's kind of like a mix-in, right? It's going to provide a bunch of additional sort of hidden functionality to this class. But what we are supposed to do is define a forward function. It should be called forward. And this is like forward pass, right, from a neural network. So, so when we get data coming in here, which is question, we forward pass that through the RAG class. And the process of doing that involves this. We first search using our search function up here, which is this, it knows about our embedder, it knows about our corpus, so it embeds this question, searches over our corpus, and returns this passages attribute from that. But this gives us a bunch of strings, or like an array of strings, I guess, something like that. And this line just formats that into a single string that we can then pass into as this context object into something called self.respond. Self.respond is just defined by ourself. So really what's happening is this thing right here. We could probably just do that. This would be pretty like bad programming, but effectively this is what we're doing, right? We're calling this. I mean, this kind of might just make things more confusing, and actually this might break as well if you kind of like are reusing this. Let me just put it back how it was. So okay, so this is the response. This is the response of forward, which comes down here. It comes out as this pred. So this prediction down here is this thing that's getting returned. And what is that thing? It's we're just instantiating this simple chain of thought where we're taking in context and a question and we're outputting an answer. And this is using that string shorthand that I was just like totally bashing. So, okay, I can talk about that after I run this. I think everyone's pretty keen to see this this getting run. And we can clearly kind of see what's happening. We're passing in a string of context here, and we're passing in a question. And that question is going to be whatever we ask, like this, into our RAG system. So one thing that's not immediately obvious is, okay, so I instantiate RAG here, right? But now when I call that, I pass in question. That's kind of weird, isn't it, right? And that's part of this DSPy.module. It kind of like abstracts away this kind of stuff where you got to just kind of know, okay, when I call this object, it's going to call the forward pass. And I don't like that sort of design because it's just like it's abstracted and hidden and weird and hard to learn. But once you get used to it, I guess it's kind of cool, you could say. I mean, just looking at this example, it's really clear to see how it works. Let's finally run this thing. Everything's saved, so I can run this. Now what's going to happen is, because it's kind of not outputting anything, and so it's taking all these things and embedding them. And online, you might see examples where instead of using sentence transformers, it's using like OpenAI embeddings. And that's fine, but those are going to cost money. So every time you run this, and it has to re-embed everything because it's not saving those from the previous, like we don't have any way of saving these embeddings. So that'll cost money every time. And it's just another like way that DSPy can end up costing us money where we're not realizing that. So looking at the history, this is what we just did. We create this system message that's like context, question, and the output fields we want are reasoning and answer. Why is that happening? That's because of the chain of thought. In a chain of thought, we want to output some reasoning, and we're inputting context and question. So this is what caused that system prompt to be generated right here. The user message then was this. This is going to be interesting because see this context? This is the result of our RAG system. These were the 3 matched pieces of content from this example I gave for the question. And the question we had was this: how many PTO days do we get per year? And the corpus was this. So inside of here, there's some of these things relate to vacation time. And let's see what we got. Here it is. Employees accrue 1.5 days of paid time off, PTO. Clearly that answers the question, and it was the first piece of matching context. And this is the user message. This is like exactly what we type in like to the API, and given the system prompt and this context, we get the answer, respond with the corresponding output fields. We have some instruction as well in here. And we have the question, how many PTO days do we get? So when we get the answer, it comes back like this. There's a reasoning field. That's because of this chain of context. The reason, like, right, this asks us, okay, make sure we output a reasoning field. So that's why we get this thing. And then we get an answer. And the reason it's called answer is because we called it answer right here. And that string, like short form signature that we did. And here's the answer and completed, like it's done. I guess this is like it's completed its work. I don't know. And DSPy, of course, parses that information into this prediction object, which looks like this. By the way, guys, if you want to learn more about RAG and agents and these fundamental ideas in AI engineering, then you should check out my course, the AI Engineer Roadmap. I have this set up as a series of lessons that you can read and sort of tick off your progress towards learning AI engineering as you go through all of the different topics in this course. But the agents are particularly interesting if you want to learn LangGraph. I talk about LangGraph and show examples of building agents using that. And most recently, I've created a whole set of videos for this course. So here's like the raw footage of me actually presenting my video and walking through it. I'm going to create this into like a full set of video lessons. It's going to be like a proper Udemy style course. And if that's something you're interested in, you can head on over to zazencodes.com and just check out what I've got there. If you're interested, you can buy this course. Thank you, and I'll let you get back to DSPy uninterrupted. And now there's one thing that's bothering me, which I want to clean up. I mentioned how I don't like this. We're going to comment this out. We're going to get rid of this. So we need context, question, and answer. And I'm going to call it RAG signature. Let's do that and put it down here. So this is a class, and it's got to inherit from DSPy.signature. And it's going to have a question, which is a string, and this will be DSPy.inputField. And we'll have context, which is a string, and that'll be also input field. This is DSPy, and then we're getting an answer out, which is another string, and that's a DSPy.output field. So obviously I can see why the creators of this library have this shorthand, because this is just like very verbose, lots to write. I still think that it should only support input fields like this. Let's see if that runs. You'll also notice I have no description in here. I'm not really doing much. Oh, okay, yeah, I just spelled that wrong. Let's go. Yeah, point being, I don't have any descriptions in here. I could put stuff like this and then give the model more guidance as to like what we want to do. But I didn't do that, and that's cool. This is the same implementation, equivalent. Nice. Okay, next for the fourth demonstration, and we're going to come back to this reg stuff, but I'm going on to show an agent. I'm going to show an agentic use case, basically just a thing that uses tools. And this is really neat. You're going to like this. So it's an expense agent that can fetch rates. It just like does some math and does some conversion rates, whatever, with a calculator. We define these calculator tools for this. So I get my logging. So I'm going to switch that to mini and get my max tokens where I want them. Nice. And okay, so we have a couple tools. There's get exchange rate, which just like fetches an exchange rate for based on some currency code, and calculate, which basically is going to run some random math. And this one has two arguments. It can take an expression, and if we do that, then we're going to just kind of validate that there's nothing kind of crazy going on, that this is math that we can properly evaluate, and then we're going to evaluate that expression using eval. Never do this. Just don't use eval. It's a bad idea. This is just an example. Don't do this at home. Okay, so then YOLO mode just kind of evaluates it no matter what, and it doesn't have this kind of check. So if you run some command that bricks your computer, it'll just run that. Anyway, the point being, we're going to provide these tools to our model. And how we do this is DSPy has this tool like object, and you can instantiate that and pass the function in. This is just like a Python function. We pass that in and we give it a name. And presumably it also has some understanding here of the tool's doc string. It certainly has an understanding of the tool's input parameters. And then we define a calculate tool as well. And then we create a React agent. I have a video on React agents and using LangGraph to create these. And you can watch those if you want to get an introduction to React. I'll put a link to that one in the video description for you. And when we're instantiating this with the same shorthand signature, we're going to take a question and we're going to output an answer. I'll probably convert that to a proper signature at the end to demonstrate that. But then this is the interesting part of the agent. They have tool calling abilities. And so we're going to give them these tools and watch them use them. This is really cool. I really like this example, and it works the same way. We're starting to see the pattern here, right? We've defined this React agent, and now I can just call that. It's like it becomes a function that I can call, and I can pass in a question. And why am I passing in this as question? Well, it's because of this right here. We called it question, but I could call it something else. Let me change this to prompt, and then down here I would actually that would become prompt, and that's how it works. So this string is becoming callable. I don't like it, whatever. I've talked at length about that. So let's run it. So I spent 200 EUR on a client dinner. What's that in USD? And is it under 75? So we're kind of like trying to get the model to think about using these tools and call these things for us. Here we go. Let's go. We'll talk about the prediction first. This is the final result, and it has this trajectory field, which explains some of the models, like it kind of explains how the model came to the conclusion it did. It also has reasoning, and then lastly it has an answer, and this is the actual final result of the language model. Now, of course, an LLM wouldn't really need tools to do math this simple, but I love that it did use the tools. We can see that in this trajectory argument. So if I just scan through this quickly, it's difficult to read, but look at this. We're calling calc right here, and we're passing in an argument of an expression right here, and we kept YOLO as false, sadly. But this is the math that we did, and we executed that with a tool call. Hopefully there should have been a currency exchange as well. Here was the FX currency exchange. I missed that one. So it called this with tool args of currency code EUR. Observation. 1.07. So that would have been the output of the function call. That's kind of cool that they called it observation, because I guess it's like an agent. So the agent can interact with its environment, and in a way it kind of like observes what happens. So, you know, imagine this currency rate is kind of like a button, and the agent walks up and like presses it and then observes what happens. And what happened is it got 1.07. Probably reading too much into this. Let's look at what happened, because this is really cool. This is the system message, and this looks very similar to the other system messages we've seen, but the user messages are way different. It has the prompt, which was the question we asked. That's straightforward. But now it's outputting this whole trajectory, and it's got these thoughts in here, like I'll fetch the current conversion rate so I can convert 120. This is clearly using some sort of generative process. So there must have been other prompts ahead of this that we're not seeing. And it's showing what tools. This is kind of the whole, this must be multiple steps. So I'm a little confused about this. And then we get the final answer here. But let's look at the actual logs from OpenAI to understand this one. I think I just ran this once. So all 4 of these prompts would have been from the same thing. Let's look at the first one. This is the actual first thing that happened. So that, what I just showed you, that agent like did 4 different API calls. The first one was this, and it says I spent this thing, and then it has this trajectory object, and it's just like, okay, just respond with your next thought. And by the way, you've got access to these tools right here. And I want to see if it has the tool stuff. So here's where it's saying stuff like this. Okay, return USD conversion rates. That was the doc string from the tool we defined. And, you know, it takes these arguments. So that's a type string. And then this one, a safe so this is the doc string from the calc function. So it's encoding like all of this information, or it's like providing that to the model in a really well-structured way for the model to be able to do the tool calling properly. So this output here, where it's like next thought, I'll fetch the current conversion rate so I can convert 120 euros to USD. This thought is then what gets put into the next prompt. Let me show you that one. So this is the next prompt, this line right here. And that thing we were just looking at, check out how they insert it in here. So this is still the initial question, but now down in trajectory, they're inserting the output from the previous iteration. And they kind of keep iterating on this and keep doing tool calls and do that a couple more times until we get this, which is the final answer, which is must have been what I was seeing from the history response that I printed out right here. And that's an agent with DSPy. Okay, one thing I'll mention is we can kind of just switch this LLM out. So if I wanted to use like Anthropic, I could try that. Honestly, I haven't tried this yet. So let me see, Claude Sonnet 4. Yeah, and then I guess I don't want this stuff. Okay, so I can try and just run that. I'm trying to demonstrate, though, the versatility of this, because maybe it's not, I mean, OpenAI with the responses API clearly has some way of you know, like doing agentic behaviors like this, just that I need the version. And the point I'm trying to make here is that we can just kind of like swap the model out, and this same prompting strategy is going to still work. So yeah, look at that. That totally just worked. So I just kind of like totally just switched my model, but we're using the same prompting strategy, and DSPy has allowed us to like migrate our agent to another provider like that. That is really cool to me. I'm pretty into that right there. Okay, final example is the self-improving pipeline. We're going to be using GPT-4o Mini for this, because I was trying to run with GPT-5 and I was getting errors because of this temperature parameter and stuff. Anyway, so GPT-4o works for this example. That's why I downgraded the model there. Now, DSPy does a lot of stuff, a lot of different things, and that's partially why I think it's so complicated. I'm going to speak more about that in the outro. Let's focus on this final example of a self-improving pipeline. We're going to optimize this RAG-bot. This example is pretty crazy, and we're going to do that with 5 QA examples. Okay, so we have the same RAG-bot right here. This is all the same. Same sentence transformers. This is the third example that I showed a few minutes ago. And this is all the same, but this is where it starts to become different. And we're gonna change the behavior from everything we've seen above this point. We're gonna pass in some additional data and start kind of messing with our prompts in order to push the model to get different behavior based on these example use cases. This stuff's pretty cool. I'm going to try and show my best how this works using this function right here, which is just a logging function. This isn't doing anything really. I mean, it kind of it's making predictions. All right, so this is doing some stuff, but the purpose of this function is to do logging. I'm going to talk through all this in a little more detail once it's running, because it's going to take a little while to run. And this is what it'll do when it runs. So it evaluates the initial bot. So we're going to create an initial rag bot, and we're going to evaluate it on the data that I've provided above. I'll explain that. After we do that, we're going to optimize it, and this is going to cost us some money, and I'm going to try and show you all the outputs in the console. Hopefully they print there, and I can show you like how many prompts this ran, because this thing is going to run like 20 or 25, I think, 25 different API calls. And then in this one, we're going to evaluate the bot. So we'll see like, okay, after optimizing it, this is the optimized bot that we've got out of this optimizer.compile. I'll walk through all this stuff. What we're trying to see here is that after optimization, the bot should perform better. It should like do better on our intended use case. Let me kick this off, and we'll have lots of time to talk through how it's working as it runs. Okay, it's already spit out a whole bunch of stuff, and it's getting to, oh my God, it's already finished. Okay, so that worked a lot faster than before. Let's go up to the front of the logs, and then as I talk through the example, we can see some context based on what's happening here. And okay, yeah, it output a whole lot of stuff. This is the very first thing it did. It started outputting a bunch of baseline information for us right here. Let's look at where we get this. So if I look at baseline, that's because I'm calling this eval bot right here. And I'm going to follow this, like I want to explain every line of here. And so I'm going to kind of work backwards through the example. I hope that works for everybody. So eval bot is this thing right here. Let me save this. So we're taking in this bot, which is this mini HR object, and we're going to call that. And this is using the same DSPy way that we do things. We kind of have some object, and then we call it like this, and we're passing in question. Okay, where does this come from? Where does this argument come from? Let's understand that. Let's go back to bot. Let's go back to this bot. I instantiated a rag bot. Where do we think this question is going to come from? It'll probably be in the forward pass of this rag bot right here. And there it is. This is the question argument we defined in the forward pass of the rag bot. And I could make this other stuff. Like if I made this prompt, wherever I had question, I would just have to change this to prompt. This one as well. Oh my God. And then down here, I would change that to prompt. I don't want to do that. I'm just trying to show you that none of this is magic. Nice. Okay, so this was the same thing we talked about before. So you can refer to that description if you've forgotten about how this one works. But we instantiate this rag bot, and let's go back to evaluate. So we're passing that in here. We also have a data set of stuff that we want to evaluate. And what am I doing with that data set? I'm iterating over it, and I'm creating a prediction for each item in that data set. And if you're tracking things here, that means I'm calling our rag system for every single example in the data set. And every time I call the rag system, I'm going to generate an output. So I'm making an API call for each one of these, plus I'm making all of these index searches inside of my rag database. So this right here could be pretty expensive, and we're iterating over a data set in order to call this. And the data set we're using, let's figure that out. So I'm using this dev set, which is up here. And so the data set is composed of DSPy.example objects, where each example is made up of a question and an answer. And the question and the answer are up here. So this is a question in the evaluation data set, and this is the answer. So when the user asks this, we want to get this out. When the user asks this, we want to get this out, and so on and so forth. This is like a few-shot learning type idea in terms of prompt engineering, because we're giving it some examples to learn from. But we're not like explicitly including these examples in the prompt. We're asking DSPy to basically fine-tune its prompting so that it better adheres to this. It's really wild. Like, it's pretty cool. So if you're following me, we have a dev set, and we're kind of spamming this. We're kind of abusing this. In real machine learning, right, you want to do a training data set, and then you want to evaluate on a different part of it, a validation set. So these things should be different, but I'm just reusing this dev set, which is bad. And then we're using the same dev set again in the evaluation method up here. Probably what we should do is we should take the entire data set of training stuff, and then we should split it. And how I would do it is, I could be wrong about this, but I would take 15% and I would hold that out. So that would be called my eval set. And then I would take, oh my God. Okay, so then what I would do is I would take I would take another 15%, and this would be my validation set. So I'm going to say val set, and that's this one right here. So that's what I would use for validation. And then the remainder is 70%. So I would take that 70%, and that would be my train set. So that way we're not duplicating any data. I'm going to evaluate on my eval set. I'm going to validate on this on this part, and then I'm going to train on a different part of the data set. I didn't do that in this example. I'm just reusing the same data set for every single case. Whatever, it'll work. And I just wanted to get something running. And this is doing some cool machine learning stuff under the hood. I'm going to be honest with you guys, I have no idea what this does, but it's some sort of optimizer that is part of DSPy. I believe it's like the main optimizer that you would want to use for this sort of task. And this line here, like, it calls the compile method on that. That's all I got for you guys, but we're going to see the outputs of this. We're going to see what this actually does. And if someone wants to explain this in the comments, that would be awesome. That would be great. Go for it. I'll like it. I might even pin it so everybody can see that. I'd appreciate that. Right. Okay. Where are we here? Okay, I think probably we're wondering about this exact match, because we have a prediction and we're passing that through the exact match. This is super simple. We have an example, which is a DSPy example. What does that just mean? It just means it's like an object that has an answer like this. It has an answer attribute, which is a string. That's the answer we expect. So we're referencing that. The prediction is a DSPy.prediction. What is that? It's just another like thing that's very similar, and it also has an answer. And when you call that, it just outputs a string. So these are, I like these. Honestly, I like this how DSPy does this because I just find it really readable and nice for type hinting. But again, it kind of makes it confusing and hard to learn. So that was the prediction. This was the example. This returns an integer. So then I'm just summing up like how many correct we got, so we can output some logging of how this worked. And I think we've seen everything, so we can actually interpret these outputs now, which is exciting. This is our like training data set. Let me come up. This is what we define here. How many PTOs days do we get each year? We're predicting this. This is what the LLM output before we did any optimization. And it says employees receive a total of 18 PTO days. That's not what we wanted. We wanted the number 18. I just wanted to output 18. So that's gold. That would be perfect. So that's an X. We did not meet that one. How about this one? Do I need an itemized receipt for $500 team lunch? The gold answer was no, but instead we get this no, you do not need one. So the model's being too verbose. We clearly want it to be tight, and its answer is very, very, very succinct, and we're going to try and train it to do that. New hires can choose between, no, we just want the output name of the product right here. So let's see if this optimizer can tweak our model into behaving that way. And it's going to do all sorts of optimization, and I have said verbose. Where is that? I said verbose as true, and that's why it's outputting all of this stuff right here. So it outputs a whole bunch of logging from the optimization process. Now there's way too much output from this optimizer to be able to talk about, and I already kind of told you guys that I don't really know what this is doing, so I can't explain that. But what I want to show you here is all the LLM prompts that are getting triggered off. So whenever it outputs something like this, it's because it's done an LLM prompt, and it's like dataset description, program code, and so on. And then down here, we have a user message. And look at this user message. We're putting in all this program code, string signature, mini HR. This is the actual code we wrote, and we're like feeding this into the model and getting it so it kind of understands like what we're doing, and it's trying to optimize that. The response, let's see, proposed instruction. You're knowledgeable. Make sure to include step-by-step reasoning process to explain. Proposed instruction, program description, and then it keeps doing this. It runs another prompt, and we get out, what do we get out here? Answer the HR questions provided. Ensure step-by-step. Yeah, so I looked this up because I can't make a YouTube video and just cop out like that and say I don't know how this works. But it is complicated, and I believe it's something that DSPy, like it's an algorithm that DSPy implements that I'm not sure this is outside of DSPy. Like when I looked this up, I've just seen DSPy. I think it's like a DSPy thing. And so it works, it just seems really complicated. Randomly selects examples from your training set, runs them through your LM program. It does something like with Bayesian. I saw Bayesian, some sort of Bayesian optimization. Yeah, I mean, it's crazy, right? And I'm trying to illustrate here how many LLM calls, like how expensive this is. And look at all this logging and trials, and there's so much stuff going on, right? Okay, and I'll show you that in the OpenAI console as well. But let me show you the final result of this thing. Woo! So this is our optimized model. And we asked, how many PTO days do we get each year? And I said 18 days. It's so much better. Like, it's not quite gold. We wanted 18, just 18. But it's so much closer. Look at this. Do I need an itemized receipt? No. And that was what we wanted. So we get a check mark. Is the beer reimbursable? No, a beer's not reimbursable. It's close. Is a new laptop model choose? It's still more verbose. It didn't quite nail it. I really got to stress here that right here, we're just saying we want to output an answer. This is the thing that we're evaluating against. It's this answer from this RAG system. And right here, if I said something like this, answer very succinct, that would be instructing the model to do what we wanted. But I didn't do anything like that. In this example, I left this blank. So the model is just going to provide the best answer that it can. And now through this optimization progress, we went from these much more verbose answers that I showed you above to properly condensing them through this optimization process. And I want to try and get some sort of insight into that. Unfortunately, for some reason, none of those logs got sent through. In an attempt to get some logging showing up, I'm going to just upgrade my model, and I'm going to run all of these questions through a bigger model. I'm going to use GPT 4.0. Now you can see running this on 4.0 is a lot slower. Kind of ran instantly on Mini. And I also like that I'm going to try this on 4.0 because I'll be able to see the cost. And I want to see output the total cost of this example to show you. All right, that example wrapped up, and I can see the logs. Look at all these GPT 4.0 logs. Nice. Now let me filter on this model. And this is what we just ran. It's 2:40 p.m., so this is correct. This is how I'm spending my beautiful sunny Saturday in Toronto, making this video, which is fun. I'm glad you're watching. Thanks for being here. I couldn't do this without you guys. I'm being serious. Like, I appreciate you guys. This was the very first thing we saw. How many PTO days? What was the question? How many PTO days do we get each year? And we've provided the RAG context. And down here we get the answer. Employees receive 18 days each year. That would have corresponded to this. Employees receive 18 days each year. Let me prove that to you. I want to see what laptop can new hires choose. New hires can choose between these two things. Come down here. That would be this one. What laptop models can new hires? New laptop hires can choose between a MacBook Pro and Dell Pro. So this is the behavior of our RAG system before optimization. Now I want to show you the behavior after, and that should be the last four. The reason that should be the last four is because that was the last thing I did. After I look at this history, this was the very last thing I did in this session. I asked for the optimized outputs, and look how good this one did. Actually, whoa, GPT 4.0 did way better than Mini. It actually like perfectly nailed this sample data. Let's pull these answers up. And this one, MacBook Pro and Dell. This was the very last one we ran. I want to see this example here. I'm going to click this, and I should see it down here. MacBook Pro and Dell XPS. That's exactly what I wanted to see. I'm pretty psyched about that because now I can see what the optimized model looked like. Like with all this optimization, what did we actually end up asking it? So the system prompt was like this. We're giving some input. Okay, and adhering to the structure, your objective is you're an HR expert. So we've created this kind of concept around what the agent is, which I never said that. This is something that was created through the optimization. Next, we're providing it basically examples. What I'm saying is we provide an entire history of a conversation. So this isn't like a one-off prompt. This actually ends up being like the 5th, or maybe this was even later, prompt in the series. And then we give this question, and then we give the context. But like leading up to the question, there was a whole conversation that was carried out. That's what the optimization process did for us. Let me see if I can find the cost of this. Here's my usage on this project over the month. And you can see today we just spent $0.25. So I actually don't know the exact cost of that last demo, but it's on like the order of cents. Very, very, very cheap. But I'll stress like how simple it was. What will cost a lot is when this data set becomes really big. When you want to optimize some LLM thing on many, many, many examples in this type of set right here, it's going to become very expensive. And so if you're doing this in practice, you definitely want logging around cost, and you definitely want a way of saving state, like persisting what you've done in terms of your training. And all that's possible with DSPy. This video truly only scraped the surface of what this thing can do. By the way, these little chunks here were from some GPT-5 videos that I filmed earlier. You could check those out if you're interested. That's all I have for you today, but if you've enjoyed this video, I'd appreciate a like to indicate to me that I should make more stuff on DSPy. I'd be pretty interested in doing that because this stuff's super cool and it's complicated enough that I think people can really benefit from tutorials like this. So let me know that. Give me a positive signal by leaving a comment and a like, something like that. And if you subscribe to my channel, that really helps support me here as well on YouTube. Now at the end of these videos, I like to share some of my thoughts on what I've just done. And I wasn't sponsored to make this video. DSPy is amazing. It's super cool. Came out of Stanford. It's clearly backed by some really amazing algorithms and some smart stuff. It's clearly really confusing, but it's also under active development. So sadly, everything I showed you in this video someday will just be like almost completely useless because everything will have evolved. The API will have changed. This stuff will always work on this version that I've pegged in the requirements file. But for practical purposes, there's eventually going to be security vulnerabilities and like nothing lasts forever, right? But okay, so coming back to DSPy and my thoughts on it, I think I shared most of them throughout the course of this video. I wish there was just one clear way of doing things, and the fact that there's these multiple ways just makes things more confusing. The tutorials and documentation, they attempt to cover so many use cases that I don't know where to start with this thing. That's why I think this video is really helpful, because it's a clear place to start to understand the foundational parts of this library. But it can do so much stuff, and it's kind of overwhelming, actually. I also think that's going to be a problem in terms of maintainability. We saw some of that in this video where I'm trying to use ChatGPT-5 and the self-improving pipeline did not work for ChatGPT-5 right now. That will be fixed, and that's cool, but how about the responses API? This is still using chat completions, which isn't as efficient as the responses API, so that's something that needs to be upgraded. And for every LLM that's supported, every time that upgrades, we now need new integrations into DSPy if we want to access those things. So GPT-5 has like reasoning effort, we can set that, or verbosity. Maybe we would want to do that, but now how do we do that? I mean, I can set the temperature and the max tokens, but do I have access to these more like underlying, more like niche arguments and parameters that OpenAI makes available to me? What about stuff from Claude? So what about web search? What about tools? So it's going to be really hard for libraries like DSPy to keep up at the pace that AI is evolving. Those are my final thoughts on things. So if you guys are enjoying this and you want to keep learning from me, I'm going to link a couple related videos on the screen right now. I appreciate you watching this long all the way to the end. Thank you, and namaste.